So far, we've considered a possible interaction that we could get between eye contact and gender and thought about how to describe that interaction. But this is just describing what's going on in the sample. So maybe the lines weren't perfectly parallel, but this might have just occurred by chance, right? Maybe there's actually no interaction and that the lines just ended up a tiny bit crooked because of sampling variability. So we're going to do a formal test for an interaction. First, let's think about how we would modify that additive model to take into account interactions. So basically, the interaction effects are the difference between the group means from the real data, just calculating the averages, and the values predicted by the additive model. So I've got the real group means here. Remember, when we say the additive model, we mean the model with no interaction. So remember, no interaction means that the effect of eye contact is the same regardless of gender. So like here, we can see to go from no eye contact to eye contact among the female officers was an increase of 3.3 points in the rating system. So if there were no interaction, then we could just add 3.3 and we'd get 12.75 for the male officers. And 3.3 is that 1.65 times 2. It's just a different way of showing the model because you're starting from no and going to yes versus starting at the overall mean and then going to no or yes. And we can do the same sort of thing for the gender effect. So if we want to go from female to male, we're going to subtract 3.9, and that's going to be true whether you're talking about no eye contact or eye contact. So then the interaction effects are the difference between what we got in the real data and what the additive model predicted. So in the real data, the mean for female officers who saw the photo with no eye contact was 13.6. If we look at the difference between that real data and the additive model, if we subtract them, then we get a difference of 0.25. Let's do the same thing for male and no eye contact. 9.2 minus 9.45 is negative 0.25. Maybe kind of recognizing a pattern already. 16.4 minus 16.65 is negative 0.25. And 13 minus 12.75 is 0.25. So it turned out once we had that very first cell, we could figure out what all of the rest of them were because they needed to sum up to 0. And so we actually say that this has degrees of freedom equal to 1 because once we had that first cell, we could determine everything else. All right, so let's add that to our model. So the way that it's written right now is the additive model because you have a gender effect and you have an eye contact effect and they're totally separate. But we're going to modify that with an interaction term. So we're going to add 0.25 if we're talking about a female officer who saw no eye contact. We're going to subtract 0.25 if it was a female officer who saw the photo with eye contact, minus 0.25 for male and no, and plus 0.25 for male and yes. So basically we're starting off with our additive model, but we're making these little adjustments in case there's an interaction. So just intuitively, it seems like these are pretty small adjustments. We can also see this if we look at the graph of the real data. So this is the means for the real data. You can see that the lines look pretty close to parallel. Right? So it seems like no interaction might actually be a reasonable assumption here. Maybe the little deviations from that were just by random chance. So let's test it. So we want to start off by calculating the sum of squares for the interaction. And again, we're going to use the effects as a starting point. So I'm going to do 0.25 squared. And because they all are the same when we square them, I could just multiply that by 4, right? Because we've got 4 different categories there, 4 different groups, and they're all 0.25 squared. And then there were also 5 individuals in each group, right? 5 ratings per group. So I'm also going to multiply that by 5, and I put it all together and I get a sum of squares of 1.25. So you can see that number in the effect test table. To calculate the F statistic, I'm going to take the mean square for the interaction and divide it by the mean square for error. So the sum of squares for interaction was 1.25. And we said there was only 1 degree of freedom because once we had one value in the table, all the rest of it was determined. For the mean square, I'm going to take things from the ANOVA table. So I've got a sum of squares for error that's 97.2, and I'm dividing it by the degrees of freedom, which is 16, and I end up with an F statistic of 0.2058. And then I can use the F distribution to calculate the p-value. So I'm going to use the F with 1 degree of freedom for numerator, that comes from the interaction, and 16 for the error. And I would need to go back to this F distribution, but this time I'm going to put in 16 for my denominator degrees of freedom. And already I can see that 0.2 is pretty close to the left-hand side. That seems like a pretty small F statistic, the kind of thing that could definitely happen just by random chance. But let's go ahead and calculate the p-value. So I'm going to change this value here to the F statistic that I calculated. And that's where that p-value comes from, 0.6562. Okay, so here we have a very large p-value, larger than any reasonable alpha level. So I would describe this evidence as very weak evidence, and we're always talking about the evidence against the null and for the alternative. So in this case, very weak evidence of an interaction between these two variables, an interaction between eye contact and gender. Okay, so very weak evidence. Obviously, that doesn't necessarily mean that the null hypothesis is true. That doesn't mean that there's no interaction between eye contact and gender, but at least that seems like a reasonable assumption. So if we wanted to go forward assuming that eye contact and gender were totally separate effects, that there was no interaction between them, that seems like a reasonable thing to do. In other words, it seems reasonable to use the additive model that we started with without adjusting it for interaction. But it's important that we tested it first before we decided to use that simpler model.